First of all, Sham, what a wonderful storytelling. It got me goosebumps for somebody who has been in industry for since the 2G days, setting up 2G towers with absolutely blank, no wireless connectivity to a town getting lit. And here we are, where it is kind of taken for granted. So, lovely storytelling. I love it, Second part, before I start my bit, I want to talk about underscoring making telecom as an essential service and making it, giving it a ubiquitous access. Like here, we we set up big buildings, we set up big airports, we set up big tunnels, we set up big metro stations, and then we arm twist the telcos to come and pay top dollars to provide essential service, right? I think in my mind, the way we give ubiquitous access to power, to safety, we should give ubiquitous access to telecom. As telecom operators, we are not shying away for making the investment on our side. But let us make the access not an investment. Let make the access a ubiquitous access, and then we will make sure that the telecom services are really top notch in all the infrastructure of India. So I really join you in underscoring that point that telecom should be treated as essential service, not afterthought. And ideally, as an Indian, I would like my telecom access to be made available to me as and when the infra access is made. If a new metro station is opened, I want my mobile to work fully. So let's hope somewhere it works like that and we are able to do our bit and the infrastructure builders are able to do their bit. Okay, so Sham talked about past, so let me talk about a little bit of future. There cannot be a telecom, or any forum for that matter, where there is no talk about AI. So I use this forum to talk about what can AI do for us. Given the time I have, I will like to share a few things. There are two kind of things. One is inward facing, which is outward facing, inward towards our telcos, and outwards towards, you can say, what our industry is going to see the change. I will start from bottom, network orchestration or automation. We have been doing automation for a long time using machine learning kind of systems, which is rule-based. So you need a human's intelligence to come in to set the right rules and the right guardrails and the automation to work. I think with AI agents coming in, this is becoming more and more self-learning, and we are seeing more and more efficiency. So AI is real, AI is impacting our telecom operations, and I can already see faster detection, faster self-healing, things like this happening on the AI. So we need to make sure as telecom industry, we use it for everything from design, from operate, experience, everything this should be used. And it is on Airtel side really helping us. Second is resource utilization. While power, as Shyam mentioned, is coming down, power per gigabyte, per GB is coming down, but still we have a lot of power needed by the industry. As we consume more telecom services, there are more towers which are coming in, we'll need more power. Each tower will be more efficient, but can it be more efficient? Yes. Today, using AI, you can be more efficient. For example, in Airtel, we have an AI-based model with which we manage the telecom capacity during the 24 hours. And we shut down excess capacity when there is no need. And in few milliseconds, you are able to bring the capacity back as and when there is a need. Earlier, we used to have rule-based. That means in the night, 12 to 6, you shut down capacity. Sundays, you shut down capacity in commercial areas, and so on and so forth. But it was less efficient. Moment we have moved to now almost for a year to a AI-based, self-learning, autonomous, energy-efficient, energy management process, we are able to, in the go, shut down capacities and bring them up and give a great experience as well as save a lot of cost. This was not possible if there was no AI, and I believe we need to do it more and more. We can do it in capacity management, we can do it in resource management, and we are actually, as industry, using it. So I think that is the second use of AI as far as resource optimization is concerned. Anomaly detection and prediction. For anomalies, today we are still, not today, I mean, yesterday we were still dependent upon human. There are alarms which systems throw up. There are traffic changes which system throw up. There are a new firmware causing some problem somewhere which systems throw up. And there is an alarm, somebody has to watch it and correlate it and trigger a remedy. But with networks so big, which are pride of India, one of the biggest networks in the world are in India. How do you make sure we do not depend upon humans' alertness and human skill to detect these anomalies? It is today possible that you can build network AI-based anomaly detection. So whenever there is a micro fault or it is predicted to be faulty, that is where we are able to go and fix it. And you put agents so that you can not need to look, you can just type in the agent common English language, tell me where the network is, traffic is poor, or we did upgrades yesterday, tell me how the performance is, things like that. And these are all helping. These are not new news for you all. I'm sure you are using in some form or the other. Of course, we are using AI in our day-to-day life also. As you can see, the slides are becoming more sharper than the ones which we were making earlier. And we are using nice cartoons made from AI tools. Shyam's slides were AI. This slide is AI. So at least we are no longer dependent upon somebody to create a nice graphics for slides. Now slides are sharper. I want to talk about something else, which is the top. Traffic classification. Before I talk about traffic classification, I want to share with you a change which is happening. We all talked about AI. AI was largely a training use, which means we were training our models on the data we have. It could be any model. It could be telecom, it could be traffic engineering, it could be power, it could be anything. We were training our models. And they were building large data centers, which were used for training. That's why large GPUs, large powers, all were needed to build these large training AI data centers. My friends, this is changing. AI traffic is shifting to inferencing now. What does it mean? It means that on the go, all the models we have trained and you have now put the right data to make it reference, you want to consume that data. This is going to change your and my life. One, I will talk as a citizen or a human being. Second, I'll talk as a telecom ecosystem person. Let's talk about a human being. We will have, we just heard Apple introduced a real-time translator in your ear using their AirPods. You can use and you can really real-time have real translation of a different language being spoken to you. Suppose you were not able to listen to English. If you're using those real-time translators and you wanted to listen in your language, say French, you can listen my communication. Today it is possible. It was launched few days back. Of course, there were some use cases before that as well. Real-time AI camera. We are using cameras in our cars used by our field staff, where there is a camera which is looking at the occupants of the car. In a real time, that camera is detecting first, are everybody wearing a safety belt? Is the right number of people there in the car? They are not overloaded. They are also looking at whether the driver is alert or not. They are also looking at whether suppose he's drowsy or is the driver using a phone. Real time, we are able to call that car and saying, because the AI detects that the driver is using a phone while driving, he can be unsafe not only to himself but the other occupants and people on the road. This was only possible by AI. But what is really happening? Really happening is that image is being sent to some cloud application which is inferring that this is an unsafe behavior and sending you an alert. The previous example, the voice is being recorded, real-time translated and fed back. This is inference fed back into your ear. I give you third example, which is two different examples of inferring. One is driverless car. Driverless car, we all know, drives, sees the camera and does all the safety measures and is able to brake if there is somebody in front. But driverless car, the edge is on the car itself, but it cannot depend upon the safety brake for somebody to, in some cloud, in some latency to happen and then advise the car to brake. It would be too risky. So, but car is big, it has big battery, it can consume a larger processing on the spot. So the edge for the driverless car is on the car itself. And they real time tell the car to brake, accelerate, honk, whatever is needed. But look at robot. There is a robot, we are seeing all these robots nowadays being demoed by many companies including Tesla, where the robot has to real time do some action. But a robot cannot carry so much of battery. If it was, it will become very bulky. It will not be so nimble. It cannot climb the flight of stairs. It cannot do those exercise. So the robot is real time talking to some edge. If it is factory premises, the edge could be in the factory. But if it is outside, it will be in outside. Robotics are going to be around us very soon. There will be a lot of tasks which will be done by robots. But those robots will depend upon a real-time inference of what they see, what they hear, and take action accordingly. What will happen to it? They will be talking to edge data centers to infer the information in a real time. So this is what is going to change in our life very soon. Inferencing is going to become big. I gave you a few examples. There can be many more, where inferencing will be needed. What it does to you and me? First of all, the big AI data centers, which were probably training data centers, maybe in US, not in India, will convert into distributed data centers. Distributed data centers will need to be closer to the application. In case of a robot in a factory, it will be in the factory itself. But in case of something, suppose you're wanting your real-time glasses to tell you about what is happening, glass will be communicating to a cloud and inferring those photos and feeding you that this is what this image is, this is what this building is, this is what that is. They will be talking to the cloud. Now the application could be low latency need, or application could be okay mid latency need. For example, translate can be mid latency, but maybe a robot who is walking on a street like you and me, not like a curated environment, will probably need a faster response. This will change the way you and me build telecom networks. One, edge will be important. First time, low latency application of 5G would be important. Because if you are inside a building, you can use Wi-Fi 6, Wi-Fi 7, and you will get low latency. But if you are outside, the only savior is 5G. If you are using, let's say, a camera to detect unsafe behavior in an airport or this hotel, you will need the edge to be responding faster. So you will need to build edge data centers. Latency importance of the network will be more important, and we will see more and more application. First time we'll see that speed is not the only thing. We will also need, like in this camera example in a car, speed is important. You are uploading a real-time image which is of a camera people. It has not to be grainy so that the AI can read it. But then the response has to be low latency to raise the alarm. At one stage, if you really find it is unsafe, you may want to shut down the car. Tomorrow, it may be possible that the car gives you a reverse control and you can slow down the car or shut down the car. This will need a low latency response. This is happening. You will need traffic classification in our network, which means your network should be capable of tracing. This is an AI low latency demand request of the network, and this is a normal download of a large file, what is happening, and you have to treat that network in a different way. It is possible today to do AI-based network detection of various kinds of network traffic and take action accordingly. Again, telecom from a normal connectivity will come back into an even more important role we'll play in day-to-day, where the AI applications, for them to work seamlessly, telecom will be in the center of it. The performance of telecom networks will not be any longer good to have, will be a must-have need, because there will be essential life-saving applications using AI will run on it, but they will need a low latency, high connectivity, fast giving network resources, and an edge cloud to work. So good news is we are back in game with AI. Good news is finally we will see some use cases of 5G which are beyond faster speed and high speed downloads. Finally, we will see slicing applications. Finally, we will see low latency applications. Finally, we will see faster network resource management application. And this is future to come. And I have no doubt that with our innovative minds and our creative minds, India will be leading the world in not only thinking of these services, but also driving this servicing at scale. So I welcome you all to contribute to this, and I really hope we can not just be proud of saying we have the largest 5G network. In 3 years, we have grown the 5G network. We have covered all the districts, which is very thing to be proud of, because if we don't cover, the services will not be available to every citizen of India. But we should say so many innovative services are now running in India on AI, powered by innovative Indian applications, powered by at-scale Indian telecom networks. That's my thoughts for you. I hope they are thought-provoking for you to start thinking differently for tomorrow. Good luck.